Okay, we're going to pick up with example 3 using a u substitution. We are looking for an expression and its square. So the expression is u equal to the square root of x, and if I square that, I get x. So when we replace x with u squared and the square root of x with u, we get a nice quadratic equation that's fairly straightforward to solve. We can solve this one by factoring. U minus 3 times u plus 2 is equal to 0. So that means that u minus 3 is equal to 0, or u plus 2 is equal to 0. So we're going to get two solutions for u. U is 3, or u is equal to negative 2. Now don't forget we have to do the back substitution step. So we're going to replace the u's with the square root of x. And so now we need to solve the equation the square root of x is equal to 3. We can solve that by squaring both sides. X is equal to 9. Or we're going to solve the equation the square root of x is equal to negative 2. And of course here we can square both sides and we get x is equal to 4. However, this solution is an extraneous solution because, take a look at this equation, the square root of 4 is not equal to negative 2. The square root of a number can never equal a negative number. So we're going to reject that solution, and we're just going to accept the final answer of x equals 9. Be sure to box your solution so we know which is the final answer. And I'm going to uncircle this one that I emphasized here just so that we know that that's not a final answer. All right, let's take a look at B. X minus 6 times the square root of x plus 8 is equal to 0. This one can be solved similarly by letting u equal the square root of x and u squared is equal to x. And when we replace these, we get u squared minus 6u plus 8 is equal to 0. This can also be solved by factoring. U minus 2 times u minus 4 is equal to 0, so u minus 2 equals 0, or u minus 4 is equal to 0. So u is equal to 2, or u is equal to 4. Now we're going to replace the u's with the square root of x, because remember, we were asked to solve for x, not to solve for u. U is just a strategy that we're using. So if the square root of x is equal to 2, then x must be 4, because the square root of 4 is equal to 2. If the square root of x is equal to 4, then x must be 16, because the square root of 16 is equal to 4. And as it turns out, both of these solutions are valid. We can certainly check them in the original equation. So for instance, if I use 16 minus 6 times the square root of 16 plus 8 should equal 0. So 16 minus 6 times 4, which would be 24, plus 8 is equal to 0. That's true. And if we check the solution x equals 4, then 4 minus 6 times the square root of 4 plus 8 should equal 0. Or 4 minus 6 times 2, which is 12, plus 8 does equal 0. That one checks as well. So I'm going to accept both of those solutions. But really, we're going to know if we have an extraneous solution from the square root equation. All right, well, let's take a look at C. C is similar. You'll notice that one of the exponents is 2 times as big as the other. Let u equal x to the 1/3 power, and then u squared would be x to the 1/3 the quantity squared. When we raise a power to a power, you multiply the exponents, and 1/3 times 2 is 2/3. So that means that the x to the 2/3 power can be u squared, and x to the 1/3 power can be u. Now we can solve this one by factoring. U minus 6 times u plus 4 is equal to 0. If u minus 6 is equal to 0, then u equals 6. Or if u plus 4 is equal to 0, then u is equal to negative 4. We've got to do our back substitution step, and that's x to the 1/3 is equal to 6, or x to the 1/3 is equal to negative 4. And x to the 1/3 really represents a cube root of x, so we can solve by cubing both sides. If we cube both sides here, we get 216, and if we cube both sides here, we get -64. Notice that we don't generate an extraneous solution for a cube root equation, whereas we can generate an extraneous solution for a square root equation. All right, let's try D. So in D, we're going to let u equal y to the 1/3, and then our u squared would be y to the 2/3. So u squared plus 12 is equal to 7u when we back substitute. I'm going to move all terms to one side of the equation, and then factor u minus 3 times u minus 4 is equal to 0. So that means that u minus 3 is equal to 0, or u minus 4 is equal to 0. That will give us solutions of u equal to 3 or u equal to 4. Don't forget we've got to back substitute. So y to the 1/3 power is equal to 3, or y to the 1/3 power is equal to 4. And again, y to the 1/3 represents the cube root of y. We can undo the cube root by cubing both sides. If we cube both sides, we get y is equal to 27, or y is equal to 64. Both of those solutions should be valid. And now let's take a look at E. In E, we're going to notice that we have one exponent that is twice as big as the other. So we're going to let u equal x to the -1, and u squared will equal x to the -1, the quantity squared, which is x to the -2. So now that we have 28u squared plus u minus 2 is equal to 0. All right, this is a quadratic expression that can be factored. It's not an easy factoring, but we can certainly factor it, and you can even factor it in a box if you like. I'm going to draw a box over here, and I'm going to fill in our first term of 28u squared and our last term of -2, and I'm going to split the middle term accordingly. A times C is 28 times -2, which is -56. -56, factors of it that add up to +1 are +8u and -7u. So I'm going to split the middle term accordingly, and then factor each column. So 28u squared minus 7u, we can factor a 7u from that. And 8u minus 2, we can factor a 2 from that. And then 28u squared plus 8u, we can factor a 4u from that. And then on the bottom, the only thing that we can factor is at -1. So 7u plus 2 times 4u minus 1 is 28u squared plus u minus 2. So I'm going to write those factors. 7u plus 2 times 4u minus 1 equals 0. If we set 7u plus 2 equal to 0, we'll get a u value of -2/7. And if we set 4u minus 1 equal to 0, then we get a u value of 1/4. Now, let's remember what u was. U represented x to the -1. So x to the -1 is equal to either -2/7 or x to the -1 is equal to 1/4. You know what we can do when we have an x to the -1 to solve for x? We can raise both sides to the -1 power. Because remember that we multiply exponents when we raise this to the -1 power, and -1 times -1 is +1. So that's going to give us on the left x, and on the right, anything raised to the -1 power is just its reciprocal, so -7/2, or its reciprocal 4. So we get two solutions, -7/2 or 4. F is very similar, so u is equal to y to the -1, and u squared will equal y to the -2. So we're going to get u squared minus 2 equals u when we substitute. I'm going to move the u to the left side of the equation, and then factor u minus 2 times u plus 1 is equal to 0, so u minus 2 is equal to 0, or u plus 1 is equal to 0, in which case u is equal to 2 or u equals negative 1. And let's remember that u represented y to the negative 1 power, and so I'll replace my u's with y to the negative 1, and then I'm going to raise each side to the negative 1 power. And the negative 1 power just means take the reciprocal. So y to the negative 1 to the negative 1 is y to the 1, or y. 2 to the negative 1 is 1/2. And on the other side, the reciprocal of negative 1 is also negative 1. So we get two solutions, 1/2 and negative 1. All right, we have one left to do, and I think this one may be fairly obvious what to let equal to u to simplify this equation. U should be equal to the square root of x minus 2. And so that means that u squared is the square root of x minus 2 squared. So I'm just going to replace the square root of x minus 2 squared with a u squared, and the square root of x minus 2 with a u. And now we have this nice quadratic equation to solve. I'm going to do it by factoring here in a box using the AC method, since this one is not one of our simpler quadratic expressions to factor, because a is not equal to 1. So I'm going to put our first term, 3u squared, in this upper left box, 2 in the last one. 3 times 2 is 6. Factors of 6 that add to negative 7 are negative 1, so negative 1u, and negative 6, so negative 6u in the other diagonal box. The left column has a common factor of 3u, the right column a common factor of negative 1. The top row has a common factor of u, and the bottom row has a common factor of negative 2. So this factors into 3u minus 1 times u minus 2, and so setting 3u minus 1 equal to 0, u will be equal to 1/3, or setting u minus 2 equal to 0, u is equal to positive 2. And let's remember what u represented. U represented the square root of x minus 2. So the square root of x minus 2 is either equal to 1/3, or the square root of x minus 2 is equal to 2. Let's solve the easier of the two equations. The one on the right, we can add 2 to both sides, and we get the square root of x is equal to 4. Square both sides, x is 16. On the left here, we can multiply all terms by 3. That may be the easiest thing to do. And then we get 3 times the square root of x is equal to 7. Now we can square both sides. Squaring both sides, we'll get 9 times x is equal to 7 squared, which is 49. So that's going to give us an x value of 49 over 9. So we're going to get two values here, 49/9 and 16. You can give them in set notation, or you can just write or in between them and box that. I know you have probably been wondering, hey, we have all these methods for solving quadratic equations, factoring, square root property, complete the square quadratic formula. When do I use each one, and what are the pitfalls that I need to look out for? I'm so glad that you asked that. So, a quick note about them. Complete the square works on any quadratic equation, no matter whether the solutions are rational numbers or whether they are irrational or imaginary. Quadratic formula also works for solving any quadratic equation, but our factoring and square root properties are usually easier solution paths, so we're going to start by looking for those. So first, do you have an equation in the form something squared, some expression squared equals another number? If you do, use that square root property. Just take the square root of both sides. Number 2, If it's not in that form, if I put it in standard form, ax squared plus bx plus c equals 0, will it factor? If yes, go ahead and solve by factoring. You know how to do that really well by this point, and that will probably be your easier solution path. A third question to ask, is the leading coefficient already equal to 1? And is b, the middle coefficient, an even number? If yes, then go ahead and solve by completing the square, because that'll probably be an easy solution path. And if no, then go ahead and use the quadratic formula. Quadratic formula tends to be harder for all of those equations that could be solved by one of these other methods more easily. All right, so let's take a look at example 4. Each one of these quadratic equations, we're going to look at that solution path and determine an easiest way to solve. Hint, there's one of each kind here. So I have 2x squared minus 4x 4x is equal to 3. Well, gosh, first off, I notice it's not in the form something squared equals a number, so I can't use the square root property exactly here. My second question is going to be, does it factor? Well, I've got to put it in standard form first in order to see, so I'm going to subtract 3 from both sides. In order to determine factorability, we're going to look at a times c, which is -6, and are there factors of -6 that add to -4? And after pondering that for a brief moment, I've determined that no, there really aren't. Second, is the coefficient of x squared 1 and the coefficient of x an even number? The answer to that's no. So I guess I'm going to just use quadratic formula. So x is equal to the opposite of b plus or minus the square root of b squared, which is going to be 16, minus 4 times a times c, all over 2 times a. Now we've just got to simplify this. 4 plus or minus 16, and then this is going to be plus. Notice we have two negative factors there, -4 and -3, which multiply to positive 12 times 2 is positive 24, so we have 24, and then divided by 4. And so we've got to simplify this square root. The square root is the square root of 40, and 40 simplifies to 2 times the square root of 10, and we can reduce all of the terms by a factor of 2, or reduce the numerator by a factor of 2 and the denominator by a factor of 2. So we're going to get 2 plus the square root of 10 divided by 2 as a solution. All right, b. This is in the form something squared equals a number, so square root property is going to be our easiest solution method. I'm going to take a square root on both sides or undo the square, so x minus 3 must be plus or minus the square root of -8. The square root of -8 simplifies to 2i times the square root of 2, and so if we simply add 3 to both sides, we get a solution that looks like 3 plus or minus 2i times the square root of 2. Or two solutions rather, 3 plus 2i times the square root of 2 and 3 minus 2i times the square root of 2. All right, let's take a look at c. C is not in the form something squared equals a number, and it is already in standard form, so let's investigate factorability. A times c is 3 times 5 is 15. And so 15 does have two factors that add to 16. I'm going to do my factoring in a box over here. So our first term is 3x squared. Last term is 5. I'm going to split that middle term into not two equal pieces rather, but the factors of 15 that add to 16. So that would be 15x and 1x. You can write that 1 there if you like. All right, the top row has a common factor of 3x. The bottom row has a common factor of 1. The left column has a common factor of x, and the right column has a common factor of 5. So our trinomial factors into 3x plus 1 times x plus 5, And that's the product of those factors is equal to 0, so that means that one of those two factors must be 0. Either 3x plus 1 is equal to 0, or x plus 5 is equal to 0. If 3x plus 1 is equal to 0, then x is negative 1/3. And if x plus 5 is equal to 0, then x is equal to negative 5. So we get our two solutions, negative 1/3 and negative 5. And that leaves us with one more. For this one, it is not in the form something squared equals a number. When written in standard form, I think we can see that it will not factor because there are no factors of negative 4 that add to positive 2. And so we are just going to use complete the square because our first coefficient is 1 and our middle coefficient here is an even number. That makes complete the square an easy solution path. So what I'm going to do is I'm going to add 4 to both sides, and I'm going to also add a plus blank. We're going to do our complete the square picture here. So x squared, and then I'm going to split that middle term into two equal pieces, 1x and 1x. So that means our factors are x plus 1 and x plus 1. 1 completes the square, and that gives us x plus 1 squared is equal to 5. Undoing the square, x plus 1 is equal to the positive or negative square root of 5. And adding negative 1 to both sides, we get two solutions, negative 1 plus the square root of 5 and negative 1 minus the square root of 5.